Continuing our series on the 2016 GCSE physics paper from CCEA, the Unit 2 paper, and question 5 is about space. The diagram below shows our Sun and the planets that make up the solar system. Name the planets marked by numbers 1 and 2. So we've got the entire solar system here, and our job is to name these first 2 planets. Now obviously you may have a memory mnemonic, and I'm old school, so I have a memory mnemonic for 9 planets, and it's my very excellent memory just served up 9 planets. So my very means that there's an M here and a V here. My very excellent memory just served up 9 planets, and we don't have Pluto anymore, but it still gets you the order that you need. So clearly these are Mercury and Venus, and I would encourage you to have your own memory mnemonic for the order of the planets, because you never know when 2 easy marks like this will come up and you might miss them if you've got those wrong. 2. The solar system was probably formed from a large cloud of material known as a nebula. What 2 pieces of evidence support this view? So what we have in the solar system is planets all going the same way around the Sun, and the suggestion is that they all formed from the same rotating disk with localized gatherings of material forming planets that then continued to go around there. So the fact that the planets all lie in a circular plane, in other words they're all in a flat space that they're orbiting. They don't orbit in different angles to each other. They all orbit in the exact same plane, and they're all heading round the same way. So ones close in are heading round the same way as planets further out. So they're all in the same plane, and they're all heading round the Sun in the same direction. And so these are the reasons why we think that they all formed from the same swirling cloud. The Sun's gravity plays a major role in our solar system. Part 3, describe how it affects the motion of the planets. Well, remember, it's gravity that's keeping the planets in orbit, so it's gravity that's providing the force that keeps things moving around something, and we call that the centripetal force. Part 4, describe the role gravity plays in ensuring our Sun remains stable, providing energy for many millions of years. So this is the nuclear reactions that are going on in the Sun, and they're driven by gravity squeezing the material there. So we say that gravity is an inward force on the material in the Sun, and it helps then to balance out what we call the radiation pressure, which is trying to push outward from all the reactions that are going on at the center. So gravity is basically providing all the squeezing that produces the high temperatures required for fusion to occur, but then those reactions produce all this radiation pressure pushing out, and gravity is basically acting to keep that in balance as well. The graph below shows how the speed of a planet in its orbit, known as the orbital speed, depends on the length of time it takes to complete one orbit, known as the orbital period. So we have orbital speed going up the side here, and we have orbital period going along the bottom. And the data is for the 4 planets nearest the Sun. On the graph, mark with an arrow the data point that represents the Earth. So again, you need to think about your my very excellent memory just served up 9 planets. So Earth is the 3rd planet out from the Sun. And it says here, mark this with an arrow. So that is exactly what we're going to do. The short period is going to be Mercury. So Mercury is going to be this one. Venus is going to be the next smallest period. Earth will be the third smallest period. So it must be this third one. And part 4, name the planet that has an orbital period almost twice as long as we have on the Earth. So the next one out from us was going to be Mars. My very excellent memory. Mercury, Venus, Earth, Mars. Part B, stars, like our Sun, produce very large amounts of energy. The diagram below illustrates the nuclear fusion process that produces this energy in many stars. So in the first diagram, we're asked to identify these objects. We've got 4 separated protons here, and so we could describe those as hydrogen nuclei. And over here we've got a collection of nucleons, but the important thing to recognize is that there's 2 protons, and that makes whatever this is number 2 in the periodic table. So if you've got 2 protons, you live at number 2 in the periodic table, and so you must be some kind of helium. Part 2, how do we know that stars are mostly composed of the 2 gases, the nuclei of which are part of the nuclear fusion reaction shown above? So basically, how do we know that stars are hydrogen and helium? And we know this because the spectrum of light we get from stars has lines in it that match with lines belonging to these 2 materials. Okay, so the spectrum gives away the idea that hydrogen and helium are present in the stars. So light from the stars has a spectrum that contains lines belonging to these 2 elements. Most scientists believe in the Big Bang model for the formation and evolution of the universe. The diagram below represents how the size of the universe changed with time. So during the period marked A, the universe expands rapidly. What else is happening at this period? So if you think about an explosion starts off very close in and very hot, but quickly the gas spreads out from that point and expands and cools dramatically as it does that. So the main thing that would be happening during that expansion is the cooling. During the period marked B, 2 important nuclear particles were formed. Name them. So nuclear refers to particles that are in the nucleus. So the particles that are in the nucleus are the protons and the neutrons. During the period marked C, hydrogen atoms began to form and electromagnetic radiation was able to pass through the universe. This radiation has now been detected billions of years after it was first emitted. What is the name given to this radiation? Okay, so this is basically called the cosmic microwave background radiation, the CMBR. Part 4, the diagram shows that the universe is continuing to expand. What observation supports this view? So these are the observations that Hubble made about the redshift of galaxies, that galaxies seem to be rushing away from us, and that means that the universe is expanding. So light from other galaxies is redshifted, and this means that those galaxies are rushing away from us. So if all the galaxies are rushing away from us, then that supports the view that the universe is expanding. Part 5 then, according to current measurements, how long ago did the Big Bang occur? And this is very unusual for them to expect you to know a number, but it's around about 13 billion years. I think the Mark scheme allows anything between 12 and 15 billion years. And that is question 5. And it's worth remembering that this stuff has equal weight to some of the very long topics in the course, and so do not neglect the space stuff, because this has the same weight, 20 marks here, as your entire knowledge of electricity, or your entire knowledge of electromagnetism, or your entire knowledge of light or waves. So do not neglect this stuff, because there's plenty of easy marks in this section. Okay, thanks for watching.